So now we have finished the shot lighting setup, but before the rendering, I want to talk a little bit about how to use the 3D Studio Max particle system to do this kind of a rain effect. Well, technically speaking, I didn't render out the rain from 3D Studio Max. Instead, I rendered out a sort of alpha matte telling compositing software like Nuke where the rain's supposed to be, and using those alpha masks, I can later on in compositing either twist it, do some distortion to the background, or do the color correction to the background to recreate those kind of rain effect on the windshield. As you can see, in this shot, I ended up using two elements to make the whole shot rain effect. On the top left corner is the final rain look, and on the top right is a stock footage I used to give the rain a little bit more extra detail on top of the bottom layer rain matte. And the bottom layer is actually done in the PFFlow particle system. So let's go back to the Studio Max. This is a sample scene demonstrating how the particle system is set up and how it travels on a geometry surface. Right now I only have a sphere, and in the actual shot you can just replace the sphere with the windshield geometry. And the direction for the rain is traveling from left to right, imagining the wind is blowing from left to right as the spaceship travels. And here is only a very simple use of the particle flow. The first step is to launch the particle flow system. You can either press 6 on the keyboard or go under the graph editor and go to the particle flow. Here you can see the first particle tree is what I have already in the scene. And now I'm gonna go step by step, show you how to create this whole system. And we are only using the basic function of this particle flow system. So if you don't really have much experience with it, I think this process is simple enough to follow. The first thing, of course, we need is the empty flow to house everything we're gonna put in there. Basically, this is just a box where we can put all our particle emitter and everything else in there. And then we're gonna need a birth node. Birth node is basically Birth node is just a sort of a particle source telling the particle that you can spawn from frame 0 to frame 30. Here in this case, what we want is the particle is generated on top of the surface. Although it looks like the rain comes from the left, and when it touches the surface and it leaves a trail, but instead what we did is we used the geometry surface as the particle emitter, directly emitting the particle on top of the surface. So now we just need a position object node telling the system that we want to use the sphere to generate the particle. As you can see on the left, the particle is only getting generated from the left side of the geo, and before the particle travels down to the right, there's no particle getting generated or emitted from the back of the sphere. So next step we need to specify on top of the geometry where we want the particle to come from. So what we need basically is just the select couple surface, just the select couple faces on the sphere geometry, and tell the system that only generate a particle from selected faces. So we only need to select probably like, I don't know, maybe a bit more. Select about randomly a couple faces here just to give it a little variation in the source emitter. And then after we select the faces, we keep the faces selected. And now under the position object node, we just need to select the location, switch the location from surface to selected faces. So now the system will treat the selected faces we just selected as the particle source. Only those faces are going to emit particles. Okay, that's the first step, and then we need to tell those particles how fast we want to tell this particle how fast they travel alongside the surface of the sphere. We want those particles to only travel following the surface. We don't want them to go out of the surface. So the node we need is called a speed by surface, and we're gonna add the sphere surface into this node. As you can see, by default, this node will actually generate the particles and shoot them out outside the surface, and the direction of the speed is actually alongside the normal direction of that specific pace. Yeah, we just need to switch the speed direction from normal to parallel to the surface. So now, after that, we're gonna go under the speed by surface and make this node continuously control the speed. So at every frame, this node will check if the particle speed is parallel to the surface. Right now we still can see the particles sort of like circling around the surface because the speed is too fast. And since we set the type to control the speed continuously, so at every frame this speed node will try to pull those particles back to stay on top of the surface. So to fix this, we just need to turn the speed down a little bit to 10. As you can see, right now the particle is actually traveling alongside the surface. As we have a speed node to make sure that at every frame the particle speed is checked. And also here we can tweak the speed variation to give the just to make the movement more interesting, so they don't travel all together at one speed. Okay, then the next step, we need to break down the motion of the particles a little bit. So we're gonna add 2 wind field, just to use a wind like a force to blow the particle, so make it travel to the back side of the sphere, and as well as it's traveling, every particle has a sort of a turbulence field, so it will just wiggle as it travels. As you can see here, I have the wind at a very low strength, but I tweaked up the wind turbulence parameter because I don't want the wind to affect the speed. I just want to give it a little nice variation on the trajectory for each particle. So what you see here is only the first droplet of the rain, and after that we're gonna make the particle we see right now to leave a trail, so it can actually generate more particles as it travels along the surface, and the size of the particle that it generates will vary based on the time of each particle's life. So the way to do it, we need a spawn node. So basically what it does is it tells every particle we see right now, this little cross, the first droplet, to spawn the particle based on either a rate or a number. So one thing to keep in mind here is that once we connect the spawn node to our main tree, it will actually generate more particles based on the parameters. So it's better to tweak the parameters before we connect, otherwise it may actually overload the scene memory. So we're just gonna load the number for now, and then we're gonna drop it under the speed by the surface. Here's how the PF system evaluates all the nodes. So it actually comes from the top down, means the birth comes the first and the position object. So it's kind of important to put the right node into the right order. Right now we got everything, we got all the first droplet movement figured out. Now we just need to drop the spawn node right under the speed by the surface. The first droplet is leaving a trail. We need another independent module to make sure that all the new particles, they stay on the surface of the geo. And as soon as we add the geo into the lock and bound node, as you can see, the new particles, they are now staying at the place where they got generated. That's exactly what we need, because we don't want the secondary particles to travel along the surface as well. And this lock and bound node is basically trying to lock the particles onto either the surface or the object. And then we can even set the limit. So it means if the particle travels faster than the speed, it would just get out of the surface. And right now we can see there's the gap between each particle is a bit too big, because the gap between each particle is too big, we may want to decrease it. The one way to do it, we can increase the spawning rate so we get more particles. This should fill the gap a little bit better. We got some nice movement here. And the next step, we need to tell those particles like what kind of shape, either 3D shape or 2D shape they should present. And what we need to do is we're just gonna drop a shape node and then set it to sphere 20 sides, so it doesn't really, make this seem pretty heavy. And as soon as we drop the shape node there and change the displace mode to geometry, now we can see every particle right now is replaced by an actual sphere that has 20 sides, and we can tweak the shape size. This is the uniform size right now, and then we need to make those sides sort of scaling based on the age, based on how long this particle has been here, because as the water staying on the glass surface, the size of each droplet actually will decrease over time. So now we need to do the same thing. We need to do the same thing to our particle system, is that we need to apply a scale node that make those particles scale down as the time goes by. And the way to do it is we add a scale node, and under the scale type we set from override once to relative successive. We give it a rough range, like how much we want the particles scaled down, and then give a little variation so we don't get the same scale for each particle. That might be too much. Give it like 5. Here you can play with these numbers to see what works best in your scene. And here I might need more particles to be spun just to make the trail more just to fill the gap a little bit better. We got some very nice water trail on the surface of the sphere, and as you can see, because we add the scale node, those spheres actually they will scale down over time. We didn't use any fluid simulation, and it's just a very cheap way to use the particle system to do a rough to render out a matte, something like this that you see in the final. Because we just need the movement in general. We just need the movement in general of the rain, and then we can do whatever the water texture, water distortion later on a nuke. So this is pretty much it for the setup, and I also include this project file in the project package. You can also look into it just to see the parameters that I set up for every node if there's something that you're not really clear. And the good thing is that because everything is sort of procedural, now if we rotate the wind, all the direction of the movement is actually going to be affected by the new wind direction. Another good thing about the system is that here I only add 2 wind forces, and you can even actually add a gravity force, so to make the rain behave more realistically, just to follow the gravity direction. So if we hide the base geo itself, and if we click render right now, let me actually set up disable the GI so we can actually get a faster render result. So you can see, because we didn't do any texture on it, it's just basically render out the geos. It's a really fast render. This will help us a lot down the line, that if we need to tweak the motion a little bit better later on in the shot, or we can quickly go back to here and get a new render like 20 minutes or something.
Purchase genuine tutorial. Enjoy the question answering from course tutor in the long term. Join the exclusive Facebook group and learn from each other. Also, you can sign up with Yihu.com. Search for the course ID. Obtain the full learning courseware, project files. Follow us on Facebook. Get closer to become a master in CG field.